Okay, welcome. We are doing Chapter 9 on Probability, Lesson 5, which is on the fundamental counting principle, which honestly is going to make your life 10 times easier. It's really cool. So specifically what we're going to be learning today is to use the fundamental counting principle to find the number of possible outcomes in a sample space. So we'll be using the fundamental counting principle instead of making like the tree diagrams and the tables. And then we'll also be using the fundamental counting principle to help find probability. So our vocabulary term for today is the fundamental counting principle. And the definition is if an event M can occur in M ways and is followed by an event N that can occur in N ways, then the event M followed by the event N can occur in M times N ways. So now that's very complicated, but I will explain a little bit better. So basically, if you have two events happening after each other, so if you're going to flip a coin and then you were going to flip another coin, then you would take the amount of outcomes that you have with the first event and multiply it by the amount of outcomes in the second event. So, for example, if you had a coin, you were going to flip a coin, there are two possible outcomes that you have when you're flipping a coin, and that is heads and tails. Then you had a number cube. There are 6 different outcomes that you can have, 1 through 6. It has the numbers 1 through 6 on it, you roll it. If you multiply 2 times 6, you're going to get 12, and that is the total amount of sample space in this event happening. Because there are 2 events happening right after each other, you can just multiply the outcomes together, and you get the total. So now, this is the definition that I said just earlier. So if M has M possible outcomes and event N has N possible outcomes, then the event M followed by event N has M times N possible outcomes. So now, like the example in the vocabulary, this is the same question. So find the total number of outcomes when a coin is tossed and a number cube is rolled. So, like we found out earlier, we know that a coin has 2 possible outcomes. We can multiply that by the amount of outcomes a number cube has. So it's 6. So that would equal 12. So we know that there are 12 total outcomes. So now I checked with a tree diagram to show you that the fundamental counting principle works. And we can see that we have 6 outcomes here and 6 outcomes here, meaning a total of 6 outcomes. So for this one, find the total number of outcomes from rolling a number cube with sides labeled 1 through 6, and choose a letter from the word numbers. So that would be N-U-M-B-E-R-S. That's what it means by choosing a letter from the word numbers. Then find the probability of rolling a 6 and choosing an M. Now, we can find the total sample space through the fundamental counting principle, and then we have to figure out how many total we have, and then how many out of the total this option is. So I'd like you to pause the podcast, use the fundamental counting principle to find the total, and then find the probability. So I know that a number cube has 6 different outcomes, and the number of letters in numbers is 7. So that's 7 different outcomes. And I multiplied 6 times 7, so there are a total of 42 outcomes. And since the probability of rolling a 6 in an M is only one favorable outcome, the probability of rolling a 6 and choosing M is about 1 out of 42, or 2%, which I did long division to find that it was 2%. Number 3, find the number of different jeans available at the jeans shop. Then find the probability of randomly selecting a size 32 by 34 slim fit. Is it likely or unlikely that the jeans would be chosen? So once we find the probability, we have to see if it would be likely or unlikely. So I would like you to pause the podcast and try this one on your own, using the fundamental counting principle to find the total amount of outcomes, then finding the probability and deciding if it's likely or unlikely. Now be aware that there are 3 different outcomes, so you'll be multiplying 3 different numbers. So I multiplied the amount of different sizes, which is 5, then by the lengths, which is 3, and then the styles, which is 3. And I found that it's 45 total. And selecting a size 32 by 34 slim is 1 out of all of those 45 different options. So I know that it's 1 out of 45, or 2%. And so the probability of selecting that is very unlikely that would happen at random, because you only have a 2% chance of selecting it. So now we'll be practicing the fundamental counting principle and comparing probabilities in class. Make sure that you are writing down any questions that you do have and be ready to work on some problems. Have a great night or day.